All right, peeps. So this is the last video, hopefully, of the ethanol lab on how to make some moonshine. And we need to talk about how to do the calculations. What kind of calculations are required? What am I expected to do? What kind of product am I should end up with? So we're going to first start talking about the reaction itself. And like any reaction that we have talked about this semester, we need an equation. So that equation is C12H22O11. And that is sucrose. This is my sugar that I'm using that I've weighed out in the lab, okay? And then we're going to add to that a little bit of water and a little bit of yeast. And the yeast is going to kind of be a catalyst. Okay, that is the thing that's breaking down the sucrose into alcohol, right? We said that the yeast eat the sugar gets converted, they burp CO2, and then they pee out basically ethanol. All right, so ethanol is CH3CH2OH. And then our other product, like we said, they burp, is CO2. All right, but this equation is not balanced. And this is one of the few equations that you're going to see this summer that is not a 1-to-1 ratio, meaning that every molecule of sugar does not give us one molecule of alcohol that we should be ending up with a product for, right? So what are the numbers that go in front? What's the balanced chemical equation? Well, a 1 is in front of sucrose in the balanced chemical equation. A 1 is also in front of the water. However, when the yeast breaks the sugar down based on the number of carbons and hydrogens and oxygens, you can see already this equation is not going to work out. It's not the same on both sides. We have 12 carbons right here in sucrose, right? And then if I count the number of carbons in total over here, I get 1 from the CH3, another one from the CH2, and then another one from the CO2. There's only 3 that are represented there. And I have a total of 12. So how can 3 get multiplied in order to give me a 12? Well, a 4 is probably going to come into play, and it does. So here is the balanced chemical equation that you will need to use for the ethanol lab. So that means when you are asked to calculate the theory yield. All right, so theory yield, you do it like you've always done it. You put your starting amount over 1, and then you bring in the dimensional analysis, right? So if this is grams of sugar, you've weighed that out, you know what that should be. Those are the grams that you will use in the equation. You need to convert gram to mole. And you do that by using formula weight, just like you've always done it before in the past, right? Well, this is mole of sugar, so I'm going to put S for sugar. So mole of sugar goes on the bottom, and we need to convert that to mole of alcohol. And I'm going to put A for alcohol. Well, what are the numbers here? Well, most of the time, 1s go there, right? That's typically what we've seen all summer long. We've basically have seen a 1-to-1 ratio every single time, but not this case, not this time. So 1s don't really go there. I've got to look at the chemical equation in order to figure that out. So up here in the equation, there's my sugar, and there is a 1 that's directly in front. So there's mole of sugar. So a 1 actually does go there at that position. However, the mole of alcohol, if I go up to the equation, I'm going to see a 4 right here, right in front. That 4 is the mole ratio. So because there's a 4 in the chemical equation, then that 4 has to go here in the dimensional analysis problem. That means that for every 1 molecule of sugar that breaks down, I will get 4 molecules of alcohol that is released. That is how the thing decomposes or breaks apart. Okay? Then finally, in the next step, you do this just like you do all the rest of them. Mole of the alcohol on top, mole of the alcohol on the bottom. You need to get to grams of alcohol. And again, formula weight will be the connector there. So grams per mole is the unit for formula weight. So there's the proper setup that you will need to do in order to calculate the theoretical yield for the alcohol that you produce in this lab. So that's the number one equation, the number one calculation that you're going to have to do. Theory yield, and the reason that I'm covering it is because it's slightly different this time, and the reason is that it's not a 1-to-1 ratio. Okay? All right, now, what else do we need to do? Well, let's talk about the alcohol. When I collect it into my receiving flask, drip, drip, drip down into this flask. The question here is that how do I know that this is ethanol, right? I see a liquid. I've collected it during the boiling point, which is what it should be. But how on earth can I prove that that actually is ethanol that's in that sample or in that container, right? Those are the questions that we have to solve for. Well, the very first thing that we will want to do is not make any assumptions at all. So we're going to put this thing on an infrared spectrometer, and we're going to run it. And hopefully what we will do is that we will prove through the IR spectra that it is an alcohol group first. So I need to take a look at the OH band in the infrared spectrum, and I'll talk about that in just a second. If it is an alcohol, then I want to go another step further, and I want to see if I can prove that it's ethanol. So our FTIR system will actually go through and it will match the infrared up to a database. And if it is ethanol, then hopefully the FTIR will identify it as so. So what are the things to look for in the infrared? Well, in the very beginning of the infrared, if you have an alcohol, no matter what kind of alcohol it is, methanol, ethanol, propanol, butanol, who cares? Your infrared will have a huge dip that comes up or down and back up. And if you see that, and this happens around 3,000, 3,500, if you see that big wide dip that takes place in the beginning of the infrared, then that's a very good sign that you have an alcohol on your hands. So that is proving that, yes, we do have alcohol. Once we identify that we do have an alcohol, and hopefully that it is ethanol, we need to go another step further, and we need to talk about purity here. And when we talk about purity, we're looking at percentage. What percent of this is alcohol? So how do we do that, right? And if we get a percentage, then we can convert that number to the proof. So hopefully, I know I'm not going to get 200 proof, which is perfect. That would be 100% alcohol. We said the best we could probably get is 95% alcohol. So 95 times 2 is 190, right? So 190 proof is typically the best that we can get. So if I'm in the ranges of 180 or more, then that means my distillation was performed the right way, my collection was performed the right way, my testing was done accurately, and that's the threshold that you need to go over. So over here to the side, I'm going to write 180 proof. That is what you want to accomplish in this lab. Well, if you take that 180 and you divide it by 2, you're going to get 90%. So we want you to produce a product that is 90% alcohol. Well, what's the other 10%, right? If this is 90% ethanol, then the other 10% should be water. And that water is coming over because you cannot fully separate the alcohol and water from each other. And then we're giving you a little bit of wiggle room because we know that some of the water, maybe some extra, will come over in your distillation flask on the collection side of the setup. Okay, well, how do I know the percentage? What do I need to do in order to figure this out? Well, the key here is you're going to have to graph. And the graph is going to tell you what percentage you actually have. All right, so in your laboratory notebook, well, not really your notebook, but your laboratory manual, you will see on page 234, if you're using the red edition, this table. And this table is 27.2, and it says density and composition of ethanol water solutions at 20 degrees. So here gives you density values in this very first column. And it's saying that if you have a density of 0.914, then that is equivalent to a 50% mass of ethanol. And if you're going by volume, 57.8% volume. Okay, so what does that actually mean? Well, mass percent is based on weight, right? So what they're doing is that they're taking the weight of the alcohol and comparing it to the weight of the entire sample, okay? And then volume percent is the same thing, but it's in volume. So instead of weight, they're taking the milliliters of alcohol that's present, dividing it by the total volume, and that's giving you the volume percent of the alcohol that you have in your sample. All right, so you need to form a graph, and you probably will do this in a pre-lab question, but you need to generate an Excel spreadsheet that has your density on one axis and the proper percentage on the other. Now, I'm not going to tell you which percentage that you need. You don't need both of these. You only need one. So in the lab manual, there's some background information. The background information will tell you what percentage is used in order to calculate proof. Is it mass percent? Is it volume percent? That's up for you to figure out. But once you make your graph, what will happen is that you will end up with a chart that looks something like this. All right? So density, percentage of alcohol, I'm not telling you which one it is, and then here is a line that goes through those data points. So you will need to do a regression line, and you will need to do an R-squared value, just like what's listed on the screen. And once you generate that, once you have your equation, you will obtain your density of the sample in the lab. Now, density is plotted on the y-axis in this example. So that means in this equation, density value that you have gotten will go in for the y value. And you will solve this equation for x. And x will be the percentage. Once you calculate the percentage, you will then need to convert that over to proof. And the background in the lab will explain how to do this. So what I'm telling you is read, right? Okay. Keep in mind, this graph might look different than yours. It's just an example. Also keep in mind that this equation might be different than yours. Again, it's just an example, just to kind of walk you through on what to do when you go into the lab. All right, so that's the important table that you will need in order to finish this lab out. So make sure that you get a copy of that. Make sure that you do an Excel spreadsheet. You need to see that graph. You need to print that graph. You need to put that graph into your lab notebook. And you will probably need that graph before you finish the pre-laboratory assignment as well, because there's going to be questions that concern it. So that graph is going to be very important to you. Okay? All right. So that's going to be the graphing part of the laboratory analysis. So in the lab, I'm going to do density. When I do my density value, I plug it into the equation from the Excel. When I plug it into the Excel equation, all of a sudden, I'm going to get percentage. And that percentage is related to proof. Again, we want you to have 180 proof or more. And if you don't, look at your grade sheet. You know how much that we're going to take off for it. And if you're happy with that, turn it in. But if you're not happy with that, you will need to re-ferment, you will need to redistill, and you will need to clean up your process to turn in a better sample at the end of the day. Okay? So make cotton happy. That's the moral of the story. You want cotton to be very proud of you because right now you're taking this class in North Carolina and you don't want to be outdone by anyone else because North Carolina needs to represent. So make sure that you make him happy. Make sure he doesn't come for you. But at the same time, we're going to be a little bit cleaner. We have cleaner glassware. We have a cleaner space to make the alcohol. We have better equipment to determine if it's alcohol or not versus poor old cotton back in the day. So that's it for the alcohol lab. So good luck with the lab. Good luck on the pre-lab questions. This lab is going to require 1 week of fermentation, and then you're going to have to go back to it and finish it up after 1 week. So this could be a little bit lengthy. And if you have to redo it, keep the timeline in mind. Because if you're redoing it, it's going to be another 2 weeks before you get data again. So use your time wisely, and I think that you'll be okay. If you got any questions, you know where we are. You know what my email is. You know what my number is. Give me a call.